Okay, simplify completely and express in terms of positive exponent. And you're given an expression. So here we should not ignore the second part of the question, express in terms of positive exponent. So our answer should not contain any negative exponents. So what if we have a negative exponent in our expression? How can we change it into a positive exponent? So to do that, we can use these identities. A to the negative nth power equals 1 over a to the nth power, and 1 over a to the negative nth power equals a to the nth power. So we have these two identities. We can use these identities in this way too. If a to the negative nth power is is a factor of the numerator of a rational expression, then we can change it into a positive power, positive exponent, by moving it to the denominator. Or if a to the negative nth power is a factor of the denominator, then we can change it into a positive power by moving it to the numerator. Okay, so keep this in mind. Then, how can you start the problem? So basically, the given expression is a power of a rational expression, right? So the base is 6, oh, sorry. The base is 6x to the negative second, y to the fifth, over 2 times z to the negative 11th. Okay? So this is a rational expression. But so we can start by simplifying this base. But there aren't many things we can do to simplify this expression because there is no common variable between the numerator and the denominator. But we can simplify the number of factors, right? 6 and 2. So they have a common factor, 2. So we can divide them by 2. So we get 3 here and 1 here. So this becomes 3x to the negative second, y to the fifth, over, we don't need to write the factor 1, so z to the negative 11th. And we raise this to the negative third power, negative third power, right? Now, now we can simplify this resulting expression by using by using this base, but I prefer this way. We can rewrite the base using these identities. I mean, the second one. So we can move z to the negative 11th to the numerator. Then we get what? 3x to the negative second, y to the fifth, times z to the negative 11th. And there is nothing in the denominator, which means the denominator is 1. So over 1. But we don't need to write over 1. So, so this is the same as the base, this base, right? So we raise this whole thing to the third power, negative third power, right? So now to simplify this expression, we see that the base of the exponent, right, this exponent, has four factors. So the base of the exponent is the product of four factors. 3, x to the negative second, y to the fifth, z to the negative 11th. And we raise the, the whole product to the negative third power. So, so what can you do? So we can apply one of the rules of exponent to this expression. So which one? We can apply this a times b to the nth power is what? A to the nth power times b to the nth power. So we raise each of the factors of the base to the nth power. But our expression is a little bit different from this. What's the difference? The base of our exponent has four factors, but this formula, this rule, has only two factors. But we can extend this formula naturally, like a, b, c, d to the nth power equals what? A to the nth power, b to the nth power, c to the nth power times d to the nth power, right? So again, we raise each of the four factors of the base to the nth power. So that means here we can raise each of these four factors, 3 x to the negative second, y to the fifth, z to the negative 11th, to the negative third power. So 3 to the negative third times x to the negative second to the negative third. So this is the power over power, so we need parentheses here. So y to the fifth to the negative third power times the last one, z to the negative 11th to the negative third power, right? Now we have four factors in our expression, and three of them are powers of a power, right? So to simplify each factor, we use the power of a power rule, that is a to the nth power to the mth power equals, we multiply the powers, so a to the n times m's power. So the first factor is fine, 3 to the negative third, and the second factor becomes x to the negative 2 times negative 3, which is positive 6, so x to the sixth power. And the third factor, y to the fifth to the negative third, which is y to the negative 15th, right? And the last factor, z to the negative 11th to the negative third. We multiply negative 11 and negative 3, so we get positive 33. So z to the 33rd power. So now we are almost done, but we have some negative powers. So now we use these identities. So what do we do? So so our expression doesn't look like a rational expression. So where do we move a negative power? So, but we can think of this as a rational expression like this. So we can move the root of negative third power to the denominator, and you can change the sign of the power. So we move the root of negative third power to the denominator, so 3 to the third, right? We change the sign of the power, so negative 3 turns to positive 3. And x to the sixth power stays in the numerator. And the third factor is a negative exponent, so we can move it to the denominator, y to the, then you get y to the 15th power, right? Because we change the sign. And then z to the 33rd power stays in the numerator. So we have four exponents in our expression, but they are all positive exponents. So this is the answer. X to the 6th power, g to the 33, the g to the 33rd, over 3 to the 3rd times y to the 15th. So this is our answer, but if you want, you can compute 3 to the 3rd power. So the denominator becomes 27 times y to the 15th power, and the numerator stays the same. So you can write either way, right? Both are fine. Thank you.